We are here for a brief overview of the resurgence of infectious disease, and let me get to chapter 10. Here it is. Let's go down one slide. So there are a number of diseases which have come back. We've never been able to totally conquer HIV, human immunodeficiency virus, also known as AIDS. So HIV/AIDS. HIV is you're living with the virus. AIDS is when the virus has finally gotten your body down to where you can't fight the virus anymore. So it was never conquered, but it's here and it's staying here. But we've got great treatments. First recognized in the U.S. in 1981, now a worldwide killer. We have medications that work here in the United States. Those medications are not available everywhere on the globe. It is caused by what is known as a retrovirus. It attacks the immune system. We currently have blood tests for screening, a screening test that recognizes antibodies within the blood fighting against this virus, and we can measure those viruses in the blood. Many drugs are available, but there is no cure. You can take, with these drugs, the virus can go down to imperceptible levels, and it is believed when an individual's blood shows imperceptible levels, meaning no evidence of the disease, that the person is no longer a carrier. How is it transmitted? In the early days, it was transmitted by sexual contact. There was the homosexual contact and heterosexual. It's both. Is the most common route of transmission, but also sharing needles is a large common route. In the early days of this virus, when I was in respiratory therapy school, that was in the mid-1980s, there was a large group of people, intravenous drug users, and it was also spread through blood transfusions. The blood supply is very safe in the United States and is tested regularly. Every unit of blood that is given to an individual is tested for HIV and a number of other drugs. A number of other bugs, not drugs. HIV can be passed prenatally from from mother to gestating infant. It can also be passed through breastfeeding. So it's extremely important for pregnant women to know their HIV status. If they are found to be HIV positive, pregnant women are given AZT. AZT is known to suppress the virus, and it will not be passed on to children. Oftentimes the infants might test positive, but what you're testing in the early infancy stage may be the mother's antibodies. The HIV status of a pregnant woman is important, so that woman does not breastfeed because the virus can be transmitted through breastfeeding. Blood transfusions, okay, it says no longer in the United States. That's because the virus is tested for. Interestingly enough, circumcision can prevent some men from contracting HIV from women. There's not as many folds in that area, but it doesn't protect women from contracting the disease from men. The treatments are good. The treatments are known as highly active antiretroviral therapy, HAART treatment. A drug combination led to and continues to lead to dramatic improvements in survival rates, reduces the viral load to undetectable levels in the blood and the body fluids. Encourage infected people to be tested and treated to prevent transmission. There are also drugs known as fusion inhibitors and integrase inhibitors. Those are the different types of drugs. You're not responsible to know those drugs for this course. Where did HIV originate? It probably originated in Africa and across species from monkeys to apes to humans. Here's the deal. A bug will start in an animal population and is transmitted animal to animal. Then it'll jump species within an animal population, so the bug will now transmit from one species to another. Then the bug will mutate and it's transmitted animal to human and then becomes an epidemic disease when there's human-to-human transmission. HIV is spread throughout global populations, usually due to disruption in lifestyles. Listen, you could have a group of people who are well managed on HIV drugs, and there could be famine, there could be war, there could be displacement. meaning large groups of people need to move from their homes, and then they no longer have access to the therapies that they need to stay healthy. HIV did spreads to Western countries due to changing patterns of sexual behavior, and especially now with international travel so prevalent and so easy. There are other viruses you've heard of, Ebola, which is a killer, and there was a huge outbreak in Africa, and there were some diagnosed Ebola cases here in the United States about 10 years ago. And now we see monkeypox, which is not as deadly as Ebola, but it is spread through infected secretions, is similar to smallpox, and interestingly enough, the smallpox vaccine and the drugs to treat smallpox work against monkeypox. Zika was on the forefront in the news, I would say about 5 to 7 years ago, transmitted by a mosquito, and it causes microcephaly in a gestating fetus or a gestating infant. What that means is it does not allow the brain to develop to its full potential. Microcephaly is a tiny brain. There are other hemorrhagic fevers that are prevalent from time to time. West Nile virus can sometimes be common here in the Northeast. That's transmitted by a mosquito. And then SARS, as we talked about. SARS-1 is the original coronavirus, and now we have SARS-2, which is COVID. Factors that lead to the emergence of new infectious diseases. We've got human activities that disrupt the ecological balance. So we damage the environment and we're closer to wildlife, and any diseases occupying a group of wildlife can now transmit easier to humans when for most of our human existence we were not in close contact with wildlife that may harbor these diseases. Modern agricultural practices can bump up these things. International travel, international distribution of food, and exotic animals. Here we go again with the animals from distant parts of the world that do not belong in suburbia USA. And then the breakdown of social restraints, once again, on sexual behavior and intravenous drug use. Influenza. All types of influenza. Influenza is an RNA virus similar to the type of virus that causes HIV, but it is not the virus. It constantly mutates, hence the reason why we always need a new influenza virus, a new influenza vaccine. There are new lethal strains that appear periodically. It was the H1N1 was a very lethal strain more than 10 years ago. The epidemic of 1918, oftentimes called the Spanish flu, killed 20 to 40 million people. Bird flu was H1N1, which started in the pig and duck. It was mostly the duck population in Asia, where a flock of chickens, a flock of ducks can number in the millions. Once that flock is infected, it can pass easily to humans. New bacterial threats that are not so new include Legionnaire's disease, which this bacteria dwells, say, in standing water, often found in catch basins on roofs of air conditioning units. Legionnaire's has also been cultured out of waterfalls inside big buildings that might have a waterfall inside. Group A, streptococci, can make people profoundly sick. It's one of the strep bugs, but it can be deadly. Other forms of E. coli can be deadly. That is found in contaminated food. And then antibody resistance can lead to some of these more deadly bugs. In other words, the bacteria mutates, is the antimicrobial or the antibiotic treatment is no longer effective, and the bug proliferates, and you could have a mini outbreak or even an epidemic. There is use of antibiotics in agriculture, growing animals. So if you've got herds of cows that you're slaughtering for beef and flocks of chicken that you're slaughtering for food, if you're using antibiotics, that can cause, we eat those animals, that can cause an antibiotic resistance within the humans who are devouring their flesh. And then MRSA, MRSA, methicillin-resistant Staph aureus, we talked about that a little bit before. in another slide section where that's there because it's methicillin resistant. That's an antibiotic, one of the strongest antibiotics we have, but it's Staph aureus and it's resistant to methicillin. Not good. TB. Now we'll talk a little bit more about tuberculosis, which is still a leading cause of infectious disease worldwide, and 1/3 of the population of the world is infected with TB. Listen, just because you're infected does not mean you are infectious. You have to have an active case of tuberculosis to be infectious. By saying 1/3 of the population is infected, that means if you took a tuberculin skin test, you are what is called PPD positive, which means you have been exposed at some point in your life. There was an early resurgence of TB in the early 1990s, and folks, when we were first learning of HIV, were most at risk, and many of them did die. TB is an airborne disease transmitted by aerosols from coughing, laughing, talking, singing, shouting. That aerosol cloud gets launched into the room, and those bugs can float in the air for a number of hours, depending upon the airflow in the room. If you have active tuberculosis, if you are infectious, you have active, not latent infection, but active disease, and you're not treated, there is a 50% fatality rate, not to mention TB causes what we call a cavitation pneumonia. It gobbles a cavitation lung disease. It gobbles up chunks of your lung. Not good. Antibiotics are effective, but they need to be taken for months and sometimes years. And if you don't take these antibiotics the way it's prescribed, it can lead to resistance, something called multi-drug resistant TB. And we even have strains that are called XTB. No antibiotic works against an infectious case. Mortality rate, once again, can exceed 50%. Now, if you've got someone with drug-resistant DOT, if you've got someone with a drug-resistant strain, they will need to be under directly observed drug therapy. So a public health worker will go to this person's home, find them on the street, they track them down, they bring them their meds, they watch them take their meds, hence the term directly observed therapy. Oftentimes these public health workers will bring food and something to drink because these drugs can make your stomach feel terrible on an empty stomach. The DOT, directly observed therapy, is the best way to prevent antibiotic resistance. 2007, the CDC revised requirements for overseas medical screening of applicants for immigration to the U.S. There is global surveillance for all of these diseases, but we have improved public health capacity to create that surveillance, to watch for these diseases, to check up on it. And we need veterinary surveillance of incubating bugs within animal population. We also have to watch for a reduction in, we have to pay attention and make sure there is a reduction of inappropriate use of antibiotics. If you use antibiotics the wrong way, if you were to take an antibiotic for 10 days, you took it for 5, you felt better, you stopped taking it, guess what? You have just set yourself up for a resistant strain of whatever that bug was. The Institute of Medicine recommends that we need new vaccines. Remember why we don't have many new vaccines? They're expensive to produce. It's a low profit margin for the vaccine companies, and they're afraid of being sued. We need new antimicrobial drugs, and we need measures against vector-borne illnesses. In other words, malaria is a huge killer worldwide. It's also a huge cause of morbidity, meaning illness. It has a huge impact on children going to school, children living to their fullest potential, and for parents going to work. And that is it.